Alright, 2011 number 1. Here we go. Get a graphing calculator on this one. So for t equals 0 to 6, particles moving along the x-axis. We don't know its position, but we know its velocity is given by this lovely equation. Acceleration is that even nicer equation. And x of 0 is 2. Keep that in mind. A. Is the speed increasing or decreasing at t equals 5.5? Well, what is the speed? The velocity, velocity of 5.5 is negative 0.45337. How do we determine if the speed is increasing or decreasing? I know the speed. Actually, what are they asking for? They're just asking, is the speed increase? They're not even asking for what the speed is. I know the speed is the absolute value of that. But how do we decide if the speed's increasing or decreasing? Remember, and this is just a little bit aside, you don't have to write this on your test at all. This is just to remind you. Speed is increasing if velocity is positive and acceleration is positive, and it's also increasing if the velocity is negative and the acceleration is negative. So if they both agree, speed's increasing. It's decreasing if the velocity is positive and the acceleration is negative, or if the velocity is negative and the acceleration is positive. See, if the velocity is positive and you have negative acceleration, that means your rate of change of velocity is negative and you're slowing down. Here, if your velocity is negative, you're going backwards, then your rate of change is you're trying to speed up in the forward direction, so you're actually slowing down to try to go faster. So we're going to use this concept here. So what is the acceleration at 5.5? It's negative 1.35851. And so your argument is the speed is increasing at time equal 5.5 since both velocity and acceleration are positive at that moment or at that time. Okay, and that's all you need. B. Find the average velocity of the particle from 0 to 6. Average velocity is 1 over b minus a, integral from a to b of f of t dt. That's a general formula. You don't have to write that. But it's 1 over 6, the integral from 0 to 6 of the velocity, because we want the average velocity. 2 sine e to the t over 4 plus 1 dt. And that's a total calculator question. And you should get 1.949. Okay. C. And since they didn't give us units, you're okay really not putting units. If you want to put units per, well, they don't, that's kind of units per, they didn't even use time, did they? So since they didn't even give us that, you're okay leaving that. C. Total distance traveled by the particle. Okay, so total distance is the integral from 0 to 6, the absolute value of v of t dt, and you can plug that in your calculator, just ABS absolute value, or absolute value, and then whatever the function is, the velocity function. You can just simply write it like this on your paper, and if you do that, you get 12.573. Remember, displacement, just for review, would be the integral from 0 to 6 of v of t dt, right? So don't use that, okay? but that's just to remind you. D. For 0 to 6, the particle changes direction exactly once. Find the position of the particle at this time. So how do we determine when the particle changes direction? Well, I know when it changes direction, the velocity must equal 0. So how do I determine where the velocity equals 0? I solve that equation. 2 sine e to the t over 4 plus 1 equals 0. And I'm going to go ahead and just graph that and look at that on my calculator. And I will get t equals 5.19522. Not going to round that yet. And so that's the critical point, or that's the point when v is 0. I can look at the graph and verify that it's changes direction, but I need to make a comment to that effect, and I can say v, because I can't just say that it's, I can say it's 0 from the graph because I get my calculus for the graph, but I need to just make a comment to it. V changes from positive to negative at this time. So now I have to figure out what is x of 5.19522. Okay, how do I figure that out? I don't know what x of t is. So how can I figure out what x of that number is? I only know the velocity. This goes back to just thinking about what's the relationship between velocity and this. Well, again, if you think of the fundamental theorem of calculus and the fact that I know this guy right here, I can put it together and go, okay, the integral from 0 to 5.19522 of v of t dt. What's the antiderivative of velocity? That's position. X of 5.19522 minus x of 0. Right? Capital F of B minus F of A. And this guy right here, I could do this on my calculator. X of 0, oops, I just thought is 2. So this is 2, so I know that x of 5.19522 is going to equal, if I add this 2 to the other side, 2 plus the integral from 0 to 5.19522 v of t dt, and you should get 14.135. Okay, there you go.